We have vectors u and v whose magnitude and the angle between them are given. And this is about whether you know the basic definition of the dot products and the cross products. So first, the dot product. Of course, you probably remember dot product as component-wise multiplication and then you add them. But what if the components are not given? How do you find the dot product? Well, use the original definition of the dot product, which is you take the norm of the first, norm of the second, and multiply by the cosine of the angle between. So according to that, if you have a u dot v, it would be norm of the first one, which is 2, norm of the second one, which is 6. Those are given here, right? And the angle between them is 30 degrees. And 30 degrees is, cosine 30 degrees is square root of 3 over 2. And I guess 2 cancels. And the answer is 6 radical 3. Now what about v dot v then? Well, in this case you have v, and the angle between v and v would be 0 degrees, right? So you end up with v is 6, the norm of v is 6, and cosine 0 is 1, so you end up with 36. Okay. Now what about the norm of u cross v? Well, you have to remember this definition of the cross product, which is that if you have two vectors u and v, then the cross product would have this as the area. U cross v would be the area. The norm of u cross v is this, and the direction is perpendicular to both. Actually, this looks more like u and v here. So let me write it like this. So by the right hand rule, the u cross v would be pointing upwards in this case. It has to be perpendicular to both. So in this case, the area of this parallelogram is given by sine of the angle theta. So you get 2 times 6 times this times sine of 30 degrees, which is 1/2. So you get 6. Okay. Now for D, if you have u cross u, this time it would be norm of u times norm of u times u and u have angle 0 degrees because it's the same vector. Same vectors have 0 degrees as their angle. By the way, this is sine. And sine of 0 is 0, so 2 times 2 times 0, it's going to be 0 because this is equal to 0. Okay, E. So you want the vector projection and then the norm of the vector projection, which should be like the scalar projection. There's a slight difference between norm of the vector projection and the component. So, component of u projected onto v is what we call scalar projection. And the formula for that is you divide, so it's really a component of u in the direction of v, so you multiply by the angle between u and v. So that's the scalar projection. The difference between the norm of the vector projection and the component is that norms are never negative, so this value will always be positive, but in the component, the scalar projection, if u and v are more than 90 degrees apart, cosine of angle bigger than 90 degrees gives you a negative number, so sometimes components can be negative. But in our case, the angle is 30 degrees, so basically E and the component is the same thing, so this is what you want, okay? So you want the norm of U, which is 2, times the angle of 30 degrees. And to understand what this really means, this is what it means. You have 30 degrees, and what you're trying to do is to come up with this projection, meaning that you draw a perpendicular line and you're looking for this length. This is what we call the component. If this is V, component of U projected onto V. And because we want this, see, you need to multiply this length times cosine of angle 30. Then you're going to get this length, right? So that's why this would ends up being 2 times radical 3 over 2. So you end up with radical 3. Okay, and then the last one, F U plus V norm. Okay, this one, it's a nice example where you try to use the fact that this would be same as this, but if you look at it, this is also same as, I can put cosine 0 here too, right? So here's what we observe. If you do V dot V, it's V dot V norm V squared, because cosine 0 is 1, right? So if you have something norm squared, that can be represented as a dot product with the self. Now, why is this anything better? Well, because we know that dot products has all the properties of multiplication. In other words, you have the distributive property and also the commutative property. So we can do U dot U, U dot V, V dot U, and V dot V, and that gives you U dot U plus twice of U dot V, because V dot U is same as U dot V, plus V dot V. Well, we already did U dot V because that's 6 radical 3, right? And then V dot V, we did that too, that's 36. And U dot U would be norm of U squared, but U norm of U is 2, so it's 2 squared, which is 4. So the answer is it's square root of 40 plus 6 radical 3. Okay, this time it seems to be asking the same type of question, but this time the vectors are given in coordinate form. So the coordinates are actually more straightforward. You don't have to think about the definitions, you just compute. That's all you need. So 2U plus V would be twice of U plus V, which would be 0, 6, negative 4. That's how you multiply the constant to a vector, the scalar multiplication. So that's going to give you negative 1, 7, and negative 4. And the norm of that would be square root of negative 1 squared, 7 squared, and negative 4 squared. I didn't put negative because negative becomes positive. So that's going to be 1 plus 49 plus 16, which is square root of 66. Okay, so that's the answer to part A. B, how do you find cosine theta? Well, cosine theta is u dot v divided by the norm of u, norm of v. And where do we get that from? Well, we get that from the original definition. We had it here, right? So that's the definition. If you solve this for cosine theta by dividing it to the other side, you get exactly this formula. So now since we have the u and v, we can actually compute this. So first, u dot v is a component-wise multiplication and add. So 0 times -1, 3 times 1, -2 times 0, divided by norm of u is square root of 0 squared plus 3 squared plus -2 squared times -1 squared plus 1 squared plus 0 squared. So you just use these formulas. The top just becomes 3. The bottom one, 3 squared is 9. 2 squared is 4, so you get 13. 9 plus 4 is the square root of 13. And then 1 plus 1, that's 2. So the answer would be 3 over square root of 26. C, the question is angle bigger than 90 degrees or is it less than 90 degrees? I know that the angle is not equal to 90 degrees because in that case u dot v should be 0, but it's not. U dot v is 3, right? So what do we do? Well, we know that cosine theta is bigger than 0 because it's 3 over radical 26. That's bigger than 0, right? And if you look at the graph of the cosine from 0 to 180 degrees, the graph goes like, it starts from 1, and at 90 degrees it hits 0 and then goes down like that. So what that means is that if angle theta is bigger than 90 degrees, cosine would have been negative, right? The only way that cosine could be positive would be the angle theta should be between 90 degrees and 0. So the answer to part C would be theta is less than 90 degrees and bigger than 0. So that's the answer to part C. Okay, let's continue. How do you get the cross product? Well, cross products are computed using the formula, which is I, J, K. Then you have 0, 3, -2, -1, 1, 0. And then you do a row expansion. So I norm 3, -2, 1, 0. That's the submatrix obtained by deleting the row and the column containing I. So you're left with this, right? And then the checkerboard of sign says I should be you should put positive in front of I, whereas you should put negative in front of J. And then again, you should put positive in front of K. Okay, so what about J? If you delete the row and column of J, then you get 0, -2, -1, 0. So you can put 0, -2, -1, 0. And then plus K, deleting the row and the column containing K gives you 0, 3, -1, 1. And that gives you 3 times 0 is 0. -2 times 1 is -2, but you're subtracting this. So it's this minus that. So 0 minus -2, so that's 2. Here it's 0 minus positive 2. So it's -2 overall, but there's a minus in front, so it's plus 2. Here it's 0 minus -3, so it's positive 3. Okay. Now what is the area of the triangle that has U and V as its size? So you think about this three-dimensional space, X, Y, and Z, and you have U being like 0, 3, and then down. So the vector U is something like this, whereas V would be -1, 1. So vector V would be over here. And there's this triangle, right? So how do you get this triangle? Well, this triangle's area would be half the area of the parallelogram. And if you recall, U cross V's norm is the area of parallelogram formed by vector U and V. And since we just want half of that, we need the triangle. So that means the triangle's area would be half of the norm of this vector. This is U cross V, right? So if you want the norm of U cross V, you need to take the norm of this, which is 2 squared plus 2 squared plus 3 squared, and that's 1/2. 4 plus 4 plus 9, that's 8 plus, so that's what it is. Okay. And then F, the volume of the parallel pipe. Okay, so volume of the parallel pipe given by 3 vectors is given by the triple scalar product. Triple scalar product is defined as U cross V dotted with W. And there are actually 2 ways to do this. If you already have the cross product, then it's a simple dot product. But you could also compute this by putting U here, V here, and W there. That's another way to do it. So it's up to you. You can still try to calculate the norm, the determinant of what is this? You put U is 0, 3, -2, V is -1, 1, 0, and then W is 2, there's no J, so it's 2, 0, and it's -1K, so it's -1. So this is what you have to compute if you wanted to find the volume of the parallelogram using the triple scalar product. But we can just do this directly because for us we actually have U cross V, which is 2, 2, 3. And you just have to do the dot product with W, which is 2, 0, -1. And the result is component-wise multiplication. And then you add them, so it's just +1. Okay? So that's the answer to F. Okay, now G. What's the component and projection? Okay, so G, component of U to V would be the norm of U multiplied by the cosine of the angle between U and V. I just drew a triangle to explain why this is true in the solution of question 1. But here, since we're given the coordinate form, it's better to think of this as norm of U times norm of V times cosine of theta divided by norm of V. Because if you do that, then the top one is same as U dot V. And the bottom one is the norm of V. And U dot V is 3. And the norm of V is square root of 2. Okay. So that's it. Okay. H. Oh, we're not done yet. We also need the vector projection of U onto V. And what you're doing is you basically want to promote this scalar to become a vector by attaching the unit vector in the direction of V. So the unit vector in the direction of V is, you normalize the vector V, And we know that this is vector v is negative 1, 1, 0, and the norm of vector v is radical 2. So that's going to be 3 over 2 times negative 1, 1, 0. Now this is a perfectly fine answer, but you could also rewrite it as negative 3 over 2, 3 over 2, and 0. Okay, H. Find the vector that is perpendicular to both u and v. Well, what do you know? That's exactly the cross product. I mean, there are many different vectors that are perpendicular to u and v, but you know, if you have u and v, then there will be this u cross v, which would be perpendicular to both. And any other vector that's perpendicular to both would have to be perpendicular to the plane given by u and v, so it would be parallel to this u cross v. So there are many vectors that are perpendicular, but it has to be parallel to the cross product. But we already did the cross product calculation. It was 2, 2, 3, right? So that's it. That's the vector perpendicular to both u and v. It's an example of a vector that's perpendicular to u and v. Okay, I. Then what about u cross v dotted with v? Well, as we said, this is perpendicular to v. So these are perpendicular. And if you do dot product between two perpendicular vectors, we know that it's going to be 0. So that's it.